Hi, BC. I thought, I had to prove to myself that this could be done by parts, and even though it's way worse than the way Liam showed us in class, it can be done. So that's very exciting for those of you that, want to see this. So, of course, Liam showed us in class, right, that we could say, oh, this is really the integral of x times x squared over x plus 1. And then we saw in the previous exercise, right, that we added 1 and subtracted 1 here. Right, we saw that in the previous exercise. Right, so this quickly became x times x squared plus 1. Oops, sorry, there's a squared on the bottom. X squared plus 1 minus 1 over x squared plus 1 dx. And of course, that is just the integral of x minus x over x squared plus 1 dx. And we know this thing is just 1/2 x squared. And then we found this one earlier, and I believe that was 1/2 ln x squared plus 1, right? That was from an earlier problem, right? Just this piece right here. Okay, so that is going to seem very, very nice and simple compared to the way that we're going to try to do this over here. And instead of using x cubed as my f, I'm going to say f of x is x squared. F prime of x is going to be 2x, of course. And if f of x is x squared, that means g prime of x would have to be x over x squared plus 1. And g of x is the integral of that, right? Which we just said down here was 1/2 ln x squared plus 1, right? And this is from that other exercise, right, that we just did. Okay, that was from the second one of those problems we did on the board today in class. So that means that this integral x cubed over x squared plus 1 dx has to be f times g, right? That's x squared over 2 ln x squared plus 1. That's kind of messy, right? Minus the integral of 2x over 2, right? So it's just going to be x ln x squared plus 1 dx. Okay, so we're now going to change colors because we're only going to be concerned about this piece right here. This piece right here with x ln x squared plus 1, right? And to do that, of course, I think we're going to want to u sub. So this is my aside here that we're going to say, oh, let's take the integral of x ln x squared plus 1 dx, and I'm going to let u be x squared plus 1, so du dx is 2x, or dx equals du over 2x. So what does that mean for my integral? Let's rewrite it. Let's say x ln u times du over 2x. Well, of course, that's just... Well, we'll maybe come over here because we'll stay over here. That equals 1/2 times the integral of ln u du. And from a previous screencast, we know this, right? That is 1/2 u ln u minus u. That's what the integral of ln is, right? So now we just need to sub in for our x, and we'll get something gross that looks like this. Ln x squared plus 1 minus x squared plus 1, all inside these parentheses. Now this looks awful, right? But we can sort of clean this up some. Okay, so this thing is really, I'm going to rewrite this as 1/2 x squared ln x squared plus 1 plus, that's just multiplying this x squared times the ln x squared plus 1, plus 1/2 ln x squared plus 1 minus x squared minus 1. Okay. Good. Oops, sorry. Minus 1/2 x squared minus 1/2 minus 1/2. Right. Because this half still has to go all over to everything. Okay, so let's take this expression now that we know and love, and let's plug it into my my original. Okay, So let's look back here where we stopped up here, and we had the integral of x cubed over x squared plus 1 dx. And we said that was equal to x squared over 2 ln x squared plus 1 minus this thing we just found. So minus x squared over 2 ln x squared plus 1. Oh, look, those things just go away. Minus, I might need another row here. Minus, sorry about this, minus 1/2 ln x squared plus 1 plus 1/2 x squared plus 1/2. So these top two terms, they cancel. And I am just left with this integral has to equal 1/2 x squared, rearranging terms, minus 1/2 ln x squared plus 1 plus 1/2, which is really, right, we can really roll this into part of c, right, part of c. So we do get the same thing here as we do right here, right? Those are the same thing. Hooray! So it can be done by parts. We just have to pick our f and g intelligently. All right. I feel so much better now. I'll see you on Wednesday.